Have you ever gazed at the night sky and wondered, how did all of this come into existence? From the dawn of humanity, this question has been a common thread uniting us all, no matter the era or culture. Over the centuries, scholars, philosophers, and scientists have proposed a multitude of theories to explain the origins of the universe. One such theory, the Big Bang, postulates that all matter and energy once existed in a minuscule, dense region that exploded into existence some 14 billion years ago. Yet despite its widespread acceptance, the Big Bang theory has its limitations. For instance, it struggles to explain what existed before the explosion or what triggered the initial expansion. These are significant gaps indeed. But what if there was another theory that could provide a different perspective on the universe's origin? Enter the Big Bounce theory, a fascinating concept that challenges the Big Bang theory. This theory proposes a cyclic model of the universe, where the cosmos goes through infinite cycles of expansion and contraction, much like a cosmic heartbeat. At the heart of the Big Bounce theory is the idea that our universe is not the first, but rather one in an infinite series of universes. Each universe, according to the theory, begins with a Big Bang, expands until it reaches a certain point, and then contracts under its own gravity, eventually collapsing in on itself in an event known as the Big Crunch. This contraction continues until all matter and energy are compressed into a tiny, dense point. But here's where the Big Bounce theory veers from the Big Crunch scenario. Instead of ending in a singularity or a point of infinite density, the collapsing universe bounces back. It undergoes a rapid expansion, resulting in the creation of a new universe. This is the Big Bounce. This process is thought to be driven by a phenomenon known as loop quantum gravity, a theoretical framework that attempts to reconcile the seemingly incompatible theories of general relativity and quantum mechanics. Loop quantum gravity posits that space and time are quantized or broken up into discrete units, much like pixels on a screen. When the universe contracts to a certain density, these quantum effects become significant, causing the universe to bounce back and create a new cycle of expansion. So, the Big Bounce theory suggests that our universe is just one phase in an infinite cycle of cosmic death and rebirth. It's a concept that's as mind-bending as it is fascinating, a theory that challenges our understanding of time and existence. But remember, this is just a theory, and like all scientific theories, it's subject to revision and falsification as we gather more data and develop better understandings of the cosmos. So, according to the Big Bounce, our universe could just be one of many in an infinite cycle of death and rebirth. The Big Bounce theory is not just an intriguing concept, but it also has profound implications for our understanding of the universe. This theory is particularly appealing to physicists because it weaves together general relativity and quantum mechanics. These two theories have been notoriously hard to reconcile. General relativity describes the universe on a large scale, while quantum mechanics explains the world of the very small. However, these theories often clash, creating paradoxes that physicists have struggled to resolve. The Big Bounce theory elegantly sidesteps these problems, providing a framework that accommodates both theories without the need for singularities or points where the laws of physics break down. Then there's the mystery of dark matter and dark energy. These elusive substances are believed to make up about 95% of the universe, yet we know very little about them. Dark matter and dark energy could significantly impact the universe's expansion rate, and thus the Big Bounce theory. Unraveling these mysteries could provide crucial insights into whether the Big Bounce theory holds water. But the Big Bounce theory isn't just for physicists. It's made a big splash in popular culture too. This theory has inspired works of science fiction, giving writers and filmmakers a fascinating new concept to explore. For instance, in an episode of the animated comedy Futurama, the main characters witness the Big Bounce while time traveling into the distant future. It's a testament to the power of this theory that it can engage both scientists and the general public, sparking our curiosity and imagination. The Big Bounce theory, like any scientific theory, is not a set-in-stone fact, but a model that best fits our current understanding of the universe. It's subject to change as we gather more evidence and develop new ways of thinking. While the Big Bounce theory may not be definitive, it opens up a world of possibilities and continues to inspire scientists and dreamers alike. If you're enjoying this video, click on like and subscribe to get notifications when we release more. When a universe that doesn't end with a big freeze or a big rip, but instead bounces back, would that thought intrigue you? That's the concept of the Big Bounce theory, an alternative perspective on the beginning and end of our universe. Unlike the Big Bang theory, which suggests our universe began from a single, infinitely dense point, the Big Bounce paints a picture of a cyclic universe. A universe that doesn't just spawn from a singularity, but evolves from the remnants of a previous universe, collapsing under its own gravity, only to rise again. It's a cosmic phoenix, birthing itself anew from the ashes of its own demise. This concept challenges our understanding of time, space, and everything we thought we knew about our cosmic home. The Big Bounce posits an intriguing perspective on the universe, a perspective that might be more realistic than we initially thought. The Big Bounce theory has been around for a while, supported by cosmologists such as Willem de Sitter, Carl Friedrich von Weizsäcker, George McVitie, and George Gamow. These minds of science showed us a new way to look at our universe, proposing a model where the cosmos undergoes a perpetual cycle of contraction, collapse, and re-expansion. This theory didn't spring up overnight. It's a product of decades of intellectual pondering and rigorous investigation. You see, back in the early 20th century, the concept of a static universe was widely accepted. But as we began to observe and understand more about our cosmos, we found evidence that it was expanding. This led to the Big Bang theory, which proposed that the universe began from a singular point and has been expanding ever since. However, the Big Bounce theory adds another layer to this concept. Instead of a one-time event, the Big Bang is just the latest in a series of cosmic bounces. Each bounce is a new beginning, a fresh cosmic cycle, making our universe much like the mythical phoenix rising anew from its own ashes. This brings us to the cosmological principle, a cornerstone of modern cosmology. Discovered through observational cosmology in the early 80s, it states that the universe, on large scales, is flat, homogeneous, and isotropic, meaning it looks the same no matter where you are or which direction you look. This principle led to the idea of an early universe experiencing an exponential expansion of space, setting the stage for the inflation theory. And then, in 1987, the term Big Bounce officially entered the scientific lexicon. It was used as a title in two articles written by Wolfgang Priester and Hans-Joachim Blohm, published in Stern und Weltraum. This was a pivotal moment in our understanding of the universe, marking a significant shift in how we perceive its origins and destiny. In 1987, the term Big Bounce officially entered the scientific discourse, marking a critical moment in our understanding of the universe. The Big Bounce theory continues to evolve, gaining traction in the world of loop quantum gravity. In this cutting-edge field, the work of a trio at Pennsylvania State University has been especially noteworthy. Abhay Ashtekar, Tomasz Pawlowski, and Parampreet Singh have been pioneering a new understanding of the universe's origins through their research on the Big Bounce theory. Their work hinges on the concept of isotropic and homogeneous models in loop quantum cosmology, a subfield of loop quantum gravity. In layman's terms, they've been exploring whether the universe is the same, no matter where you look or what direction you look in. They've been asking, is the universe truly uniform? And their findings, first identified in February 2006, suggest that the answer may be a resounding yes. But what does this mean for us? Well, it could fundamentally reshape our understanding of the universe. If the Big Bounce theory holds true, it suggests that the universe is not a one-time event, but a cyclical process, a series of expansions and contractions, bounces, if you will. This theory challenges the traditional view of a single Big Bang followed by a constant expansion. Instead, it proposes that our universe is just one of many, born from the remnants of a previous universe and destined to collapse and be reborn again. It's a radical idea, but one that's gaining ground, with numerous groups extending these results to a variety of other models. The implications are mind-boggling. If true, it could mean that our universe is just one link in an infinite chain of universes, each one born from the ashes of the last. It's a humbling thought, isn't it? To think that our universe, vast and complex as it is, could be just one small part of an even greater cosmic cycle. The Big Bounce theory, once a fringe idea, is now a significant part of our understanding of the universe, offering a tantalizing glimpse into the cyclical nature of existence. So, what if our universe is destined not for an icy death but for rebirth? Let's take a moment to reflect on the fascinating implications of the Big Bounce theory. It suggests that our universe exists in a cycle of expansion and contraction, reborn anew each time. This theory challenges our understanding of the universe, proposing a cosmos not bound by a singular birth and death. The Big Bounce theory invites us to reimagine the universe as a place of constant renewal, where every end is a new beginning. Now, isn't that a thought to ponder upon? Comment below and let us know what you think so far. We'd love to hear from you. Standing at the edge of time, peering into the birth of the universe, what do you see? A singularity of zero volume and infinite energy? Or is there more to this cosmic mystery? As we delve into the labyrinth of the cosmos, we find ourselves grappling with the Big Bang theory. This theory presents us with a paradox, a singularity of zero volume, yet brimming with infinite energy. It's as though we've hit a cosmic roadblock, marking the end of our understanding within the realm of general relativity. The puzzling nature of this singularity sparks a quest for answers, leading us to anticipate the role of quantum effects. Could these effects be the key to deciphering this cosmic conundrum? Could they illuminate the path beyond this theoretical dead end, giving us a glimpse into the true origins of our universe? This is where the Big Bang theory leaves us, standing on the precipice of a cosmic mystery, yearning for a solution. Enter the world of loop quantum cosmology research, a realm where our understanding of the universe takes a quantum leap. This pioneering field of study suggests a riveting possibility. Picture this: an earlier universe teetering on the brink of oblivion does not collapse into a singularity of zero volume and infinite energy as the Big Bang theory proposes. Instead, it shrinks to a point where quantum gravity effects become so powerful they trigger a rebound. Like a cosmic phoenix, the universe rises anew from the ashes of its predecessor. This process, a cyclical dance of death and rebirth, evolves unitarily without any breaks or interruptions. We're not looking at a dead-end collapse, but a bounce that catapults the universe into a new phase of existence. Unfathomable? Perhaps. But isn't that the beauty of cosmology? Loop quantum cosmology research has taken us on a journey from the brink of a cosmic abyss to the birth of a new universe. If we could peek into the past universe, the one that gave birth to ours, what secrets would it whisper to us? The collapsed universe that formed our own, as per Bojewald, is like an echo from the past that we're still trying to fully understand. We can determine some of its properties, yet there are limitations. Just as a whisper in the wind, some characteristics remain elusive, hidden behind the veil of certain uncertainty principles. However, the story doesn't end there. The scientific community thrives on debates and discussions. Various groups have brought forth their arguments, contesting the constraints on the change in relative fluctuations throughout the bounce. These fluctuations, they argue, are restricted by the uncertainty principle, adding another layer of complexity to our understanding of the past universe. So we stand here, on the edge of time, peering into the echoes of a past universe, and all we can do is wonder and continue the quest for understanding. Thank you to the returning watchers. We love that you're here and love creating content for you. Get friends and family involved so we can answer their questions too. What sparked the birth of our universe? For decades, the Big Bang theory held sway, painting a picture of a universe erupting from an infinitely dense point. This cosmic explosion set the stage for everything we know and see, but the Big Bang could be losing its leading role on stage. It's been the cornerstone of our cosmic understanding, the foundation upon which we've built our knowledge of the stars, the galaxies, and the vast stretches of empty space. Yet, as science evolves, so do our theories about the universe's origin. Let's dive into some of these alternative theories. In 2006, the concept of a bouncing universe emerged from applying loop quantum gravity techniques to Big Bang cosmology. This intriguing notion introduced a universe that doesn't just explode into existence and steadily expand, but instead cycles through periods of expansion and contraction. The bouncing universe theory challenges the conventional Big Bang scenario, which suggests a singular explosive beginning. Instead, this theory proposes that our universe is merely in one phase of an infinite cycle, where contraction is followed by expansion and then contraction once more, like the rhythmic beating of a cosmic heart. This theory provides a potentially more realistic model for understanding the universe's evolution. It addresses certain inconsistencies in the Big Bang theory, offering explanations for phenomena that the standard model struggles to explain. It paints a picture of a universe that is dynamic, cyclic and ever-changing, not just steadily expanding into infinity. So instead of a singular Big Bang, could our universe be part of an infinite cycle of expansion and contraction? Fast forward to 2010, and another fascinating theory emerges, the conformal cyclic cosmology. This is a brainchild of Roger Penrose, a renowned physicist who dared to challenge our understanding of the universe's origin. According to his theory, as the universe expands, all matter will eventually decay and turn into light. Imagine that everything around us, including us, transforming into pure energy. As this happens, the universe would reach a state where nothing is related to time or distance anymore, a state identical to the Big Bang. And what follows? A big crunch of sorts, leading to another Big Bang and thus continuing the cycle of existence. This theory proposes a universe that is not born once, but reborn time and again. So, could our universe be just one phase in an eternal cycle of cosmic rebirth? In 2011, a new perspective came into play with the Einstein-Cartan-Siyama-Kibble theory of gravity. Presented by Tomasz Pawlowski, this theory suggests a non-singular big bounce, a universe that contracts before bouncing back, replacing the unphysical Big Bang singularity with a cusp-like bounce. Notably, this theory provides a physical substitute for cosmic inflation. It explains why our universe appears spatially flat, homogeneous, and isotropic at the largest scales. Could this be the missing link in our understanding of the universe's origin? As we've seen, the story of our universe's origin is one of constant evolution. From the bouncing universe to conformal cyclic cosmology, each theory adds a new layer to our cosmic understanding. In the grand scheme of things, we are but explorers, forever seeking answers in the cosmic sea of mysteries. Got any questions about space, time, or anything interesting or unknown? Let us know, and we'd be more than happy to research this for you and come back with something interesting. What if our universe, the one we know, is just one of many cycles in an eternal sequence of expansion, collapse, and rebirth? Scary, right? You might have heard of the Big Bang Theory, that colossal explosion that supposedly kick-started the universe about 13.8 billion years ago. It's a tale as old as time, well, literally, but today we're going to explore a twist in this cosmic tale. Imagine, if you will, a universe not born from a singular explosion, but rather one that's been cycling through endless rounds of cosmic reincarnation. Yes, you heard that right. The universe too might have its own version of rebirth. It's like the universe has its own cosmic gym membership, going through cycles of expansion, contraction, and regeneration. So, buckle up, dear listeners, as we delve into the intriguing world of the Big Bounce Theory. It was 2012, and our understanding of the universe was about to get a major shakeup. Picture this. Scientists were stirring up a cosmic gumbo, blending together different ingredients of cosmological theories. They were taking the hearty base of Einstein's gravity, mixing in the spicy kick of ekpyrotic cosmology, and throwing in a generous helping of matter bounce. Now, what they were cooking up wasn't just a tasty treat for science buffs. This was the birth of the Big Bounce Theory, a fresh take on the universe's origins that promised to clear up some long-standing puzzles. It was designed to tackle the BKL instability, a sort of lumpy gravy in our understanding of the cosmos. This new theory suggested that the universe didn't start with a big bang, but with a big bounce. Like a cosmic rubber ball, it had contracted before it expanded. The Big Bounce Theory was cooking up a storm in the cosmology world, promising to resolve some long-standing dilemmas. So, what's this Big Bounce Theory all about, you ask? Well, let's dive in. Picture the universe as a balloon, and the Big Bounce Theory proposes that it's not a one-time inflating deal. Instead, it suggests a continuous cycle of contraction and expansion, just like a balloon being inflated and deflated over and over. Now let's talk about BKL instability. Imagine you're trying to balance a pencil on its tip. Tricky, right? That's the universe with BKL instability. The Big Bounce Theory resolves this, creating a balanced universe, like a pencil lying flat. Furthermore, consider the universe as a giant loom weaving the cosmic tapestry. The Big Bounce Theory suggests that during the contraction phase, the loom creates a nearly identical pattern each time. This pattern, or scale-invariant primordial power spectrum, helps us explain the cosmic microwave background we observe today. In essence, the Big Bounce Theory gives us a fresh perspective on the universe's beginnings, suggesting it's more of a phoenix than a one-hit wonder. Now, wouldn't it be something if we could find evidence of this big bounce? Well, some astrophysicists believe we might already have. Let's take a gander at far-off supermassive black holes like Ulysses J 1342 plus 0928. These cosmic behemoths have thrown scientists for a loop, boasting massive sizes incredibly early after the Big Bang. It's like finding a skyscraper in the Stone Age, puzzling to say the least. But here's where the Big Bounce theory struts onto the stage. It suggests these black holes could be remnants from a previous universe, persisting through the Big Bounce. Their existence might not be an anomaly, but a natural outcome of cosmic rebirth. Intriguing, isn't it? So, the next time you look up at the night sky, remember, each star might be a clue to our universe's past and future. Until then, keep your minds open and your curiosity piqued.